Hello, my dear students. Welcome back to our channel. And here I am with the third lecture of the chapter Some Basic Concept of Chemistry. And in this particular chapter, we have already dealt with two videos. First, we have covered with the significant figures and all the kind of basics. And the second video lecture we have covered about the law of chemical combinations. We have discussed about different law of chemical combinations in detail, so you can check out that. And here in this third part we are going to talk about the basic fundamental ideas that we should know before moving to the mole concept. So we should know what is AMU, what is unified mass, and how you define the atomic mass, how you define the molecular mass, what is the difference between molecular mass and molar mass, and all the kind of things we are going to discuss in this particular session. So what is atomic mass? It is a mass of one atom of an element, right? Atomic mass is mass of one atom of an element. The scale at which this atom is weighed is the atomic mass unit, or we can call it as unified mass or Dalton. These are the scale with which we are measuring the mass of one atom. And this unit, mostly we are using the unit of unified mass in our values and all. Now what is one unified mass or one AMU? One atomic mass unit. Further we are calling it as unified mass right now. So we can say it as AMU or U, it doesn't matter. So one AMU, I have defined it like this. One AMU is equal to 1 by 12 into mass of carbon 12 atom. So what is the meaning? 1 AMU is equal to the 1 by 12th part of mass of one carbon 12 atom. Why I have considered carbon 12 atom? There are a lot of atoms in the universe, right? Why I considered carbon 12? Initially I considered hydrogen, then I considered oxygen, then I considered carbon. Why? Because carbon 12 is a stable isotope of carbon. We know carbon is having carbon 13, carbon 14, but carbon 12 is the most stable isotope of carbon, we can say. And rather than that, if we calculate the values of the atomic mass of different elements, because in periodic table we got plenty of elements. When we calculate the mass of all the other elements in the periodic table with respect to carbon 12 atom, almost all the values are coming in whole numbers. If the values are coming in decimals, you know how difficult it is to calculate the values. But when you compare it with the mass of the carbon 12 atom, whole most of the values are coming in whole numbers. So we should remember the important elements and their mass. Let's say we'll discuss about few elements and their atomic masses in AMU. Okay, hydrogen actual weight is 1.008 AMU, but we are considering it as 1. Like that, all the 1 will have the some decimal values, but that decimal values can be neglected. Helium 4, lithium 7, beryllium 9, boron 11, carbon 12, nitrogen 14, oxygen 16, fluorine 19, neon 20, and it will go on like this, at least till the calcium. This how we can say that the some will have many isotopes. So the mass we have referred here is average atomic mass, and we already dealt with how to find out the average atomic mass of the element, right? Or we'll be discussing, I think we'll be discussing that. If we discuss, we'll discuss, no worries about that. Okay, now till calcium, at least till calcium you have to find out the atomic masses. These are the atomic masses of the element. And not only the atomic mass, we should know the number of atoms. How we are going to consider the number of atoms? Let's say we are considering a sample of silicon. Mass of one silicon atom is 28U. Mass of two silicon atom, 28 into 2 is going to be 56. Mass of 5 atom of silicon, 28 into 5, that's going to be 140. 20 atoms of silicon, again 28 into 20, that's going to be 560. So we can able to find out the masses of each atoms. What is the number of atom then? Mass by atomic mass, right? So we'll be getting the number of atom. Look at that. The important thing is unit should be same for all. Unit should not change. So number of atom, you got the equation for number of atom. Number of atom is equal to mass of sample by atomic mass. So you got the equation. So unit in the formula should be same. If it is u, this is also u. Okay, and let's find out the answer for this one. So you'll be getting more clarity. Look at that. 200 AMU of helium. You have to find out the number of atoms in 200 AMU of helium. Number of atoms, the equation. The equation is number of atoms is equal to mass of sample by atomic mass. What is the mass of sample they have given? Mass of sample is 200 AMU. That you are going to substitute there. Okay, 200 AMU. And what will be the mass of helium? Atomic mass of helium is what you have to substitute at the denominator. Atomic mass of helium we have already seen, that is 4. So atomic mass of helium I am writing here 4. So what is gonna get? You are gonna get 50. What is 50? 50 is the number of atoms in 200 AMU of helium. Okay, fine. Then we'll go with the next one. 3200 AMU of oxygen. Again, what you have to find out? Number of atoms, obviously. So in 3200 AMU of oxygen, what is the number of atoms present? Number of atom, again the equation is mass of sample by atomic mass. What is the mass of sample? 3200 by the atomic mass of oxygen. Its atomic mass of oxygen, that's gonna be 16. But if we talk about the molecular mass, it's entirely different, that is 32. But we are talking about the atomic mass, right? Look at that atomic mass of the sample, that's gonna be 16. So 200 by 16, what you are gonna get? 16 into 2, 32. So 200. U is gonna U is the unit, so it's gonna get cancelled. So number will be 200. Number doesn't have the unit, right? Yeah, 3200 by 16. You got the answer. You got it right. Now we'll be moving to the next question. What is the next question? Calculate the number of atoms in 46,000 AMU of sodium. Now the equation is mass of sample by atomic mass. So now we can solve it, right? What is the mass of sample? 46,000 AMU. And what is the atomic mass of the sodium? 23. So 23 into 2, you got 200. So 23 AMU you have to represent. So the number is going to be 2000, right? Am I committing a mistake? No, right? Yes. 46, 23 into 2, 46. So 3 zeros are there. 2000. Number of atoms is equal to 2000. So we will be getting the answer like this way. Then what is the need of mole then? If you are talking about this number of atoms, then why mole is required? What is mole? Mole is actually just a number, because atom is very microscopic particle. So the mass of the atom is going to be very small. But usually we are measuring the mass using a bigger units, right? Like kilogram, we are measuring the weight in grams we are measuring, but we need a little more smaller one. Not a little smaller, but a smaller counting factor is needed. So mole is just a number, another number for the counting of the number of atoms. So we'll say, what is 1 mole? They are defining 1 mole as, it is the amount that contains as many elementary particle or entities as there are atoms in 12 gram of carbon 12. Look at that carefully. Look at that carefully. 1 mole of the substance is the amount that contains as many elementary particle or entities as there are atoms in 12 gram of carbon 12. Assume there are some atoms in 12 gram of carbon 12. Then what they are telling us, 1 mole is that amount that contains atoms in 12 gram of carbon 12. So 1 mole of a substance is the amount that containing as many elementary particle or entities as there are atoms in 12 gram of carbon 12. Whatever the number of atoms in 12 gram of carbon 12, that much entities will be present in 1 mole of a substance. That is what they are telling. What is the unit of mole? It's again mole but not E. Now let's find out. From mass spectroscopy, we have found out the mass of one atom of carbon 12. From mass spectroscopy, I got the mass of one atom of carbon 12 as 1.99 into 10 power minus 23 gram. Now I have to find out the number of atom. So number of atom is mass of sample by atomic mass. Sample mass we have taken it as 12 gram. We have assumed the 12 gram of carbon 12, right? We have taken 12 gram of carbon 12. So 12 gram of carbon 12. Atomic mass, mass of one atom of carbon 12. 1.99 into 10 power minus 23. So what is the value you are going to get? 6.022 into 10 power 23. What is that? Number of atoms in 12 gram of carbon 12. What is the number of atoms in 12 gram of carbon 12? 6.02 into 10 power 23. And this value is what we are calling it as Avogadro's constant. You got the point? Yes. Avogadro constant, Avogadro number. Avogadro number is what number? The number of atom present in 1 mole of carbon 12. Number of atom present in 12 gram of carbon 12. That is nothing but number of atom present in 1 mole of carbon 12. So 1 mole of any substance, we can remember this one. 1 mole of any substance contains Avogadro number of entities. 1 mole of any substance containing Avogadro number of entities. That entities can be atoms, can be ions, can be molecule, it depends. But whatever the substance it may be, if it is 1 mole, it is containing Avogadro number of particles. So relation between AMU and gram. So we are discussing about the mass in AMU. We know that we discussed the mass in grams. So what is the difference between AMU and gram actually? We'll find out. We know the formula of AMU. 1 AMU is equal to 1 by 12 of the mass of carbon 12 atom. Mass of one carbon 12 atom is 1.99 into 10 power minus 23. You substitute that. So 1 AMU value you are getting. 1 AMU is equal to 1.6605 into 10 power minus 24. Some books they might have written it as 1 AMU is equal to 1.67 into 10 power minus 24 gram. Both are okay. There is a little difference, so you can manage. 1 ATM is equal to 1.6605 into 10 power minus 24 gram. So look at that. If I got a mass of one particular element, let's say helium. Helium mass is 4. I'm representing the helium mass is 4 AMU. Then if somebody asks what is the actual mass of helium? Actual mass of helium you have to find out by multiplying 4 into what is the value of 1 AMU? This much, 1.66 into 10 power minus 24 gram. This is what the actual mass of helium atom. You got the point? So we can write as actual mass of one element is equal to atomic weight into AMU. Atomic mass of one element is equal to actual atomic mass. Actual mass of one atom of an element. That is what you have to say. Actual mass of one atom of an element is equal to atomic weight into AMU. So 16 into 1.67 into 10 power minus 24. So 26.72 into 10 power minus 24 gram will be the actual mass of one oxygen atom. Okay. Now what is atomicity? What is atomicity? The name itself is giving you the idea, right? Atomicity is the number of atoms present in a molecule. Number of atoms in a molecule. It won't be number of atoms all the times. So atomicity means of course number of atoms. And we can say that number of ions furnished also will be using in this kind of perspective. So atomicity, what is atomicity? Number of atoms in a molecule. Let's find out. H2 molecule. H2 molecule, how many hydrogen atoms? 2 hydrogen atoms. So atomicity 2. For ozone, how many oxygen atoms? 3 oxygen atoms. NH3, how many atoms? Total atom. 1 nitrogen, 3 hydrogen, so total 4 atoms will be there. So atomicity is 4. Like that you can able to find out the atomicity. Then okay, we'll be adding one more term, the relation between AMU, gram and mole. Mass of one carbon 12, I know it is 12U. Mass of one atom of carbon 12, 12U. Mass of any atom of carbon 12, mass of one atom of carbon 12 is 12U. Mass of 2 atom, 2 into 12. Mass of 10 atom, 10 into 12. So mass of Na atom, what will be the value? Na into 12. So like that, 12 NaU. So Na means Na atoms, 1 mole containing Na atoms. So I can write mass of 1 mole atoms of carbon 12 is 12 NaU. So mass of 1 mole of atom of carbon 12 we have predefined as 12 gram. The mass of 1 mole of carbon 12 is 12 gram. So I can write as 12 NaU is equal to 12 gram, and this is gonna get cancelled. NaU is equal to 1 gram. So I can write as 1U is equal to 1 gram per Na, and I can write as Na as moles. So I can write as 1U is equal to 1 gram per mole. This is very important. 1U is equal to 1 gram per mole. The mass in AMU is numerically equal to the mass in gram per mole. So what is the atomic mass of silicon? I can say that atomic mass of silicon is 28U, and I can also say it as like 28 gram per mole. So 28 gram per mole, the meaning differs. 28U, the meaning differ. 28U is the mass of one silicon atom, and 28 gram per mole is the mass of 1 moles of silicon atom. Okay, and again atomic sulfur, mass is 32U and 32 gram per mole. So mass of one atom is what you are calling it as this one. Mass of one mole atoms is what you are calling it as this one. So mass of one mole of atom represented is gram, mass of one atom represented in U, nothing but the unified mass. So the important result what we have studied here, we will recollect everything. According to the conventional definition of AMU, mass of one mole of atoms in grams is numerically equal to mass of one atom in AMU, and it is referred as molar atomic mass. Correct, right? Yes, mass of one mole of atoms in grams, that is mass in gram per mole, is numerically equal to the mass in U. If you talk about the mass of oxygen, what is the mass of oxygen? 16U. What is the mass of oxygen? 16 gram per mole. So the numerical value is going to be the same. Mass of 1 mole of atoms in grams is numerically equal to the mass of one atom in AMU, or unified mass. So it is referred as molar atomic mass. Mass of 1 mole of atom in grams is referred as molar atomic mass. So we'll cross check important data as we have discussed. Mass of one atom that we have found out through spectroscopy is 1.99 into 10 power minus 23 gram, and we have assumed the mass as 12U or 12 AMU, and one mole containing how many entities? 6.022 into 10 power 23 entities. That entities can be atoms, molecules, ions, or any other particles. What is the value of 1 AMU? It can be 1.66 into 10 power minus 24, and 1 unified mass 1U is equal to 1 gram per mole. So the mass in gram per mole is numerically equal to the mass in unified mass unit. Okay, and what is molecule? You already know what is molecule, right? It is a group of two or more atoms of same or different elements. So type of molecules, we got two types of molecule: homoatomic molecules, heteroatomic molecule. Homoatomic molecule is like atoms of same element: hydrogen, oxygen, ozone, phosphorus, LMA. Like you can able to see that all are having same atoms. And heteroatomic, atoms of different elements: methane, carbon dioxide, water. These are heteroatomic. What is molecular mass? See, what is molecular mass? Sum of masses of all atoms present in a molecule. Like if you talk about oxygen, 2 into 16, that is 32U, and 1U is equal to 1 gram per mole. So this is going to be 32 gram per mole. But there's a difference. and sum of masses of all atoms in a molecule is 32 U, and this is for 1 mole of O2. And CO2, the mass is 44 U, and this can be written as 44 gram per mole. H2SO4, the mass is 98 U, and that can be written as 98 gram per mole as well, because 1 U is numerically equal to 1 gram per ml. Some of the major compounds are listed here, and if you by heart the molecular mass of these compounds, your time will be saved. So H2SO4, HCl, a magnesium carbonate, calcium carbonate. Just remember the mass of carbonate already. I know that carbonate mass is 60. Just fix that in mind. Then you can solve all the other molecular mass questions. And these are very important compounds like sucrose, glucose, and urea. Most of the time they'll directly ask you the question. Sucrose 342, glucose 180, and urea 60. And unit can be U or gram per mole. For one atom is U, 1 mole of atom is gram per mole. So that is how it goes. And actual mass of one molecule of a compound, likewise we have said actual mass of one atom of a actual mass of one atom is equal to atomic weight into AMU. The same way, actual mass of one molecule is equal to molecular weight into AMU. What is it? If you talk about the actual mass of one molecule of ammonia, it's going to be 17 into 1.66 or 1.67 into 10 power minus 24. You are going to get this answer. Okay, so that's it for this particular session. Next session will be discussing about the mole concept. What are the different equations to find out the moles, number of moles, and we'll be talking about the formula to find out the number of atoms, formula to find out the number of molecules, and we'll be discussing all the kind of stuffs related to the mole concept. Stay tuned. Thank you.